Welcome back, students. We were on the chapter square and square roots. So in last video I had asked you to work this problem out. What should be added to this given number so as to make it a perfect square? Now we know that the nearest perfect square greater than this number is 144. So we can easily find out that 144 minus 136, our answer is 8 should be added to this given number to make it a perfect square. Now we will try to find this answer using long division method. We will try to find this answer using long division method. Let's get started then. Okay, first thing in long division that we do is we group the numbers together. This from right hand side 36 will be here and 1 will be again here. And then what we find? We find a square number which is either equal to this first group or less than, just less than this group. Okay, so in this case 1 is the perfect square number. So we can simply write 1 here, and when we write 1 over here, where else do we write 1? This. So this is part of the square root. Okay. What then we do? We subtract the square from this here. Okay. So it becomes 0 and 36 comes down here. This group comes down here like this. Okay, then what's the next step? We add the same number to this number and we leave some space here so that we get some digit here which will make this a 2-digit number, or if there was 16 or something like that, addition was more than 10, it will make a 3-digit number. So what do we have to do? We have to take the same digit over here and multiply this with this. And whatever is the multiplication, we have to make sure that it is either equal to this or less than this. So let's do that. So if I take this equal to 1, I get 21. And if I take this equal to 2, what do I get? Oh, sorry. This equal to 2, what do I get? I get it as 44. But 44 is greater than 36, so we cannot take 2. So our first guess was right. What was our first guess? This was our first guess. And whatever digit we write over here goes up here. Now this is nearest square root for this number. Okay. So 21 ones are 21. What do we do here? We subtract this 21 from 36. Okay. Answer is 5. But the answer should be 8. So this remainder is not our answer. What's our answer? Let's see. Now, in case that we have to make a perfect square by adding some number, we don't go to remainder. We go to this square root here. And what do we do to that square root? We take it out, add 1 to it. What do we get? 11 plus 1 is 12. What then we do? We find 12 square, which is equal to 144. And now from this number here, we subtract our given number. 144 minus 136 is equal to 8. अब तो मिल गया. So this is our answer. Are you getting it? Now this was a known number. It was very familiar number. Okay, I mean the square number nearest to it was known number. So you could do this very easily. Let's do the same procedure for some other number. Now let's solve this. We are asked what number should be added to this number so as to make it a perfect square. Okay. So what do? Our first step is we group this together from right side. Now we have two groups. Now we find nearest and less than this square number, perfect square number. Looking at it, we can tell that it is 36. So what do we do here? We write 36 here, that is we subtract 36 from 39, that is first group, and we write square root of 36 here, 6, and here 6, and add 6 to it again. Okay, now let's do the calculation. 39 minus 36 is 3. When this group comes down, this 6 is part of our square root. Okay, so let's see, 6 plus 6 is 12. Now we have to find the digit here, that will write also here, and then we'll multiply. And what should be the answer? Answer should be either less than this or equal to this. Let's see. We find it by trial and error method. So, let's see, 1, if I take it as 1, I get 121. Yes, it's less, but let's see if we can find a greater digit. 2. 2 3s are 4, 2 3s are 4, 2 1s are 2. Let's see just one more digit. 3 into 3. 123 into 3 is 339, 326, 313. But this is just greater than this number here. So what do? We use the previous trial number. What was our previous trial digit? It was 2. And we write the same digit over here. Now this is the nearest square root to square root of this given number. Okay. So let's so 4 and 3. We subtract this. So what do we get here? 6, 5, 1. Now if we subtract 56 from given number, will we get the square root? Will we get the required number? No. This is not our answer. Our answer will come from this number here. So this is 62 here. What do we have to do? We have to add 1 to this square, which is equal to 63. And now we find 63 square, which is equal to, let's find out, 63. How can we find out in easier way? Yes, we write it as 60 plus 3. That is it. So 6 6 are 36. 3 6 00 plus 6 3s are 18 2s are 360 plus 9. So this is equal to 360. So this is equal to 9, 6, 9, 6. Okay, so this is our square. Now what we do is subtract from this number our given number. So we can say that 9 should be added to given number to make it a perfect square. Adding wala is a bit tricky, but you all must have thought about it and you must have come up with the same answer, right? So what I insist you is that you practice this so that you don't get confused when you actually have to solve it in exam. Okay. Now, when you have done practicing, what should be added to given number to make it a perfect square? What we'll learn is, we'll learn how to estimate a square. Now, these are not perfect square numbers. We can see that these are not perfect square numbers. But we can estimate in which two square numbers do they land. Easily it can be estimated. Observe this. 250 lies between 225 and 256, which are two consecutive square numbers, right? So, under root of 250 has to be 15 point something, right? And similarly, you can observe these perfect squares, which lies between 24 and 25. Yes, this lies between 25 and 26. So, answer should be 25 point something. These are all point something answers, okay? So, this is just estimating square root for non-perfect square numbers. If you are given any non-perfect square number, you should be able to estimate what should be the square root of it. In this method, you have to find two consecutive square numbers between which the given number lies. Okay. Now, how to estimate square roots when we know that given numbers are perfect square? Now, without actually calculating using long division or prime factorization method, how can I know that this is square of some particular number? We have to find that number. Then, by estimation method, see, first thing that we know is 1 square equal to 1, 2 square equal to 4, 3 square equal to 9, 4 square equal to 16, 5 square equal to 25, 6 square equal to 36, 7 square equal to 49, 8 square equal to 64 and 9 square equal to 81 and last 10 square equal to 100. ले लो ये. तो 25 के ऊपर जो सारे square numbers है, they all do have 6, 9, 4 and 1 in unit place, and उसके नीचे भी जो है वो भी have 6, 9, 4 and 1 in unit place, right? So what I do is I find an easier square number near it. Easier square number मतलब क्या होता है? अभी for example अभी 100 हो गया, तो 100 एक स्क्वायर नंबर है. किसका स्क्वायर नंबर है? 10 का. तो और 100 का स्क्वायर क्या है? 10,000. सो ये नंबर 100 से बड़ा है बट 10,000 से छोटा है, राइट? वी हैव दिस नंबर greater than 100 and smaller than 10,000. Then the square root of this number must be between 10 and 100, right? So what do we have here? We have concluded that square number is between 10 to 100. So we have narrowed down square root किधर रहता है. ठीक है. अभी one more easy number you know is 50. Let's see if this square root of this number lies below 50 or above it. So 50 का square क्या है? 25, 100. So is it greater than 2500? Yes. So square root lies between 50 to 100. Now next easy square number is 60. 60 का square क्या है? 3600. Now this square number is less than 3600. So अपना square root must lie between 50 and 60. इन दोनों के बीच में कभी कहीं तो भी है. अभी again I'll write it here. Okay. So 0 to 10 में जो नंबर्स है उनके स्क्वायर्स में, स्क्वायर्स के यूनिट प्लेस में ये नंबर्स हैं. तो इफ आई सेम नंबर्स होंगे यूनिट प्लेस में किसके? 11 टू या फिर 10 टू 20 के स्क्वायर नंबर्स में, राइट? उसी के जैसे 20 टू 30 के स्क्वायर नंबर्स में भी सेम नंबर्स होंगे यूनिट प्लेस में, है ना? So what I'm saying here is I have to now determine if this number is greater than 55 or smaller than 55. Okay, if this number comes out to be greater than square of 55, then what I will get? Square root must be one of these numbers. Which one will this be? Observe the unit place. So there are only two possibilities. Square root of this given number can be either 53 or 57, because in all other square numbers there is no 9 in unit place. Only in these two square numbers we can find 9. So square root of this number can only be either 53 or 57. And if we get to know that what is 55 ka square, if this square number is greater than 55 ka square, then our required square root is 57. And if it is less than 55 square, then our required square root is 53. Okay? तो सस्पेंस क्लियर करते हैं. पहले 55 का स्क्वायर निकालते हैं. 55 का स्क्वायर 5 कैसे निकालते हैं? एनी नंबर एंडिंग विथ 5 उसका स्क्वायर, पहले 5 का 25 लिख देते हैं. एंड ये 5 का 5 + 1 is 6. 6 5 are 30. मिल गया अपना आंसर. 3025 is greater than given number. So square root of this given number lies between 50 to 55. And since we know that this is perfect square, then it can only be 53, because in 51, 52, 54, all these numbers, what will be the unit place digit in squares? 151 में 1 रहेगा, 52 में 4 रहेगा, and 54 में 6 रहेगा. There is no 9 here. So the only qualified number is 53. So square root of 2809. It is 53. I hope you understood this method as well. Let's try these square numbers. Again, the same method. We know for sure that this is square root of this number lies between 10 to 100, because this is a 4-digit number. 10 square is a 3-digit number and 100 square is a 5-digit number. So square root must lie between 10 to 100. Next is 50 square is 2500. So this is definitely greater than 2500. So our square root lies between 50 to 100. Then let's see, 60 square is 3600, 70 square is 60 square 3600, and 70 square is 4900. So we can easily say that our square root number lies between 60 to 70, because this number is greater than 3600 but less than 4900. So we have concluded that I have just highlighted these numbers. Okay. So 60 to 70, this square root lies. Okay. Square root of this number. So let's see what is square of 65. We'll estimate if this is greater than 65 ka square or smaller than 65 ka square. 65 square is 25, 6 7s are 42. So this is definitely greater than 65. So what can I say after this? I can say that the square root lies between 65 to 70. And now it has become clear, apparent that the square root of 4489 is, what is it? 67. Why? Because other square numbers will not have 9 in its unit place. Very good. So can you find out square roots of these numbers? I'll give you a hint. Square roots of these numbers lie between 100 and 200. Both of these. Now apply the same method of estimation. If you have to apply method of estimation to given square numbers to find their square roots, what you will do? You will do this method and you will find out the answer. I hope this is clear to you. Now let's see this. Squares and square roots of decimals. Now you have learnt entire square and square root chapter. So I hope you can easily tell how you can apply the same methods on decimal numbers. Yes? So observe these square numbers. 0.5 into 0.5 is 0.25. This is a square number. This is a square number. And look over here. This is again a square number. One thing that you must have observed here is that after decimal points there are 2 digits, right? Here also after decimal point there are only 2 digits. Here there are 4 digits. Can you say that this is also a perfect square? Let's convert it into fraction, decimal fraction. 25 divided by 1000. Now this fraction will be perfect square only when both numerator and denominator, both of them are perfect squares. So 25, 5 into 5, 100, 10 into 10. Both numerator and denominator are perfect squares. You can see the same thing here as well. 10 into 10. You can see the same thing everywhere. 100 into 100. These are all perfect squares. Both numerator and denominator have to be perfect squares. Now here, numerator is perfect square. That's okay. But denominator, is it a perfect square? No, there should not be this 10 here, but there is. So we can say that this is not a perfect square. Now count the number of digits after decimal point. It's 3. Now let's see, I have this number here. I'm taking this number because it's easier to calculate square. This is 2000. I have to find out square of 2000. So it is 4, 1, 2, 3, 1, 2, 3. Okay. If I have to find out square of 1 by 2000, what will be the answer? 1 by 4 into 1 by 1, 2, 3, 1, 2, 3. Right? So this is 0.25. And this is 1, 2, 3, 1, 2, 3. So if I convert it into decimal number, it will be 1, 2, 3, 1, 2, 3 and 2, 5. After how many digits? Now count the number of digits here. 1, 2, 3, 1, 2, 3, 1, 2. This is 8. Now you must have observed that in perfect square numbers, you find even number of digits after decimal point. If I have odd number of digits after decimal point, it's not a perfect square. Perfect square nahi hai in that case. Okay, so you apply the same rules by prime factorization and long division as you would have used in normal division and normal prime factorization. Only you have to consider which numbers? Decimal numbers. Now let's solve few problems here. Now this is the question here. Check whether 90 is a perfect square or not by using prime factorization. What do? We write 90 over here and we factorize it. 2, 45, 3, 53, 5. Then comes 1. So is it a perfect square? No. These two factors do not have a pair. So very easy. Now this is the question that you need to scratch your head for. Remember how to represent any square number in terms of what is written here? Sum of two consecutive integers. I know you remember. Let's solve them. 21 square. What is 21 square? You should really know this by heart. Okay, it is 441. Now to represent in sum of two consecutive integers, what do? Yes, we do a equal to 441 minus 1 by 2. Equal to 440 by 2 equal to 220. Okay, then B is equal to 441 plus 1 by 2 equal to 442 by 2, which is equal to 221. Are these two consecutive numbers? Yes. So 21 square can be written as sum of a plus b, which is equal to 220 plus 221. This is your answer. Can you try these? ये तो we have done in our video. This you can easily solve. This also you can easily solve. So open your copy and solve. Let's see the next problem. Using distributive law, find the square of 43. Now distributive law is correct. A plus b whole square equal to a square plus 2ab plus b square. Okay. Why is it called distributive law? Because when we expand this a plus b whole square, now this bracket gets distributed over this bracket. Okay. So we know how to solve this. 43. So it can be written as 40 plus 3. We have to find square, so whole square. Solve it in your copy. Okay, so this is the answer here. Now let's solve next problem. Said evaluate the square root of 22.09 by long division method. Do not get anxious about decimal numbers. You will have to do the same procedure Only thing is you will have to put this decimal point up here when you use this group. Let's see. We have grouped these two together. Okay. So this, what is the nearest square? 25, but it's greater than this. So what is the consecutive square smaller than 22? Correct. It's 16. So minus 16. And what's the square root of 16? 4. So it goes over here, here. 4 plus 4 is 8. We leave this place for a digit, which will multiply the complete digit and produce an answer which is smaller than or equal to, let's see what, 22 minus 16 is 6. And now this point doesn't come down here. It goes up here. We have encountered this decimal point when we had to move this group down here. So at that point, what we do, we put decimal point up in our answer. And this is 609. So we have to find a digit over here which will make this complete number, and the same digit will go over here and multiply this number and produce a product which is smaller than or equal to this number here. Let's see. What do we do here? We do smart work. Now 8 sevens are 56. So 8 6 are 48. So this number, this digit that we have to put here has to be either this or 8. But 8 is greater than 60. The product, if I put it here 80 and 8, this is going to be 640. So if I put it here 88 and 8, it's going to be definitely greater than 640. So we cannot put digit 8 here. So what digit will we put here? Either 7 or 6. Let's start with 6. So 6 6 are 36, 6 8 are 48 plus 3, 51. Yes, it's smaller than this number. Now let's check for 7. Checking for 7. 7 sevens are 49. 7 eights are 56 plus 4, 60. Very good. 609 equal to. So this 7 goes over here. And this 609 subtracts from here. So remainder here is 0. That means the given number is perfect square. And what is this number square of? What number is that? Correct, 4.7. Therefore, we can write under root 22.09 is equal to 4.7. Very good. You can try other decimal square numbers to perfect this method here. We do not put decimal point down here. We put it up here when we encounter this group here. Okay. Now let's see this problem here. Find the smallest perfect square divisible by all these numbers. So when I say any number, don't think of a perfect square right now, but when I say any number that is divisible by given numbers, what do you think of? Yes, we think of this. What is this? LCM. So the first thing that we do here is find LCM for 3, 4, 5 and 6. It is 3, 2 into 2, 5 and 2 into 3. So the LCM will have 3, it will also have 4, it will also have 5. This number has both of these. So it will be 4 5s are correct. 20 into 3 is 60. Now 60 is LCM of, you can use any method to calculate LCM here, whatever is taught to you before. I use this method that I just showed you. Okay. So 60 is LCM of given 3 numbers. Now what we do? Is 60 a perfect square? No. What factors does 60 have? 2 into 2 into 3 into 5. 3 into 5. Right. So is it a perfect square? No. To make it a perfect square, we have to multiply 60 with pairs of these two numbers. So pair of 3 will be 3, pair of 5 will be 5. So to make this a perfect square, we'll have to 60 into 3 into 5, which is equal to 60 into 50. 15 6 are, so 900. Find the smallest perfect square divisible by these numbers. So we have a number 900 is divisible by 3, 4, 5 and 6. Now look at this question here. Read very carefully. During the mass drill exercise 6250, this is the number of students of different schools are arranged in rows such that the number of students in each row is equal to the number of rows. What does this mean? You remember the triangular pattern? I had told the number of students in each row, if it has maybe 3, 4, 7, then number of students in each row is equal to number of rows, and there are 7 such rows. 3, 4, 1, 2, 3. And it will form a square pattern. In doing so, the instructor finds out that 9 children are left out. So 9 children could not fit in this square pattern. So find the number of children in each row of the square. So what do we have to do here? Can you think of some solution? Pause this video and try to solve first. Okay. I am going to start solving here. Now, total number of students given is 6250. Okay. And they are forming square pattern. So is this a perfect square? No. In later part of the question, it is written that instructor finds out that 9 children are left out. That means 9 less than this given number forms a perfect square. Therefore, according to the question, x square equal to 6250 minus 9. What is this x? Let number of students in each row be x. Okay. Okay. So x square equal to 6250 minus 9 is, so it is 66241. X square is equal to 6241. Now, how to find out square root of 6241? It's very large number. You can either use long division method or time factorization method. But for this larger number, prime factorization will prove out to be difficult. So what are we going to do? Correct. We are going to use long division method. 6241. 62 nearest square is 64 that I can think of, but it's greater than 62. So we'll consider 49. 49 is square root of 49 is 7. So we'll write 7 here, and we'll add 7 with. Okay. So 62 minus 49. 12 minus 9, 3. 6 minus 5, 1. Now this group comes down here. 7 plus 7, 14. And we have to find this digit by trial and error method so that it multiplies and produces a number over here which is either equal to or less than this number, but it's going to be equal because it's given here that this is a perfect square. So let's do that. We find this digit here now. It's 1 here in the unit place, so the number can be either 1 or 9. 9 9s are 81. Right? So with 1 it's not equal. So let's try directly 9. 9, 9, 81, 9, 4, 36 plus 8, 44. 9 1s are 9 plus 4, 13, correct. So it's come out to be exactly equal. So this 9 goes over here. 1, 3, 4, 1. Answer is 0. That means this given number here was perfect square, and it's clearly given that it's perfect square. And square root of this number is 70. Therefore, 79 students are in each row. I hope you understood this lecture. I would encourage you to watch this complete lecture and also try to solve the questions from NCERT book and correct NCERT exam plan. When you try and solve these books, you will find where you are not able to solve questions and what part of this video you have to watch again. So, thank you for watching this video. Make sure that you solve long division method problems because that's where students go wrong. A lot of students I have seen that they cannot solve using long division method. So what I want you to do is, I want you to practice long division method and all of the questions based on it. See you.